This is your video for section 4.2. In this one, we're going to talk more about the graphs of the sine and cosine functions, but we're going to do some translations. So things like horizontal and vertical shifts, horizontal and vertical stretches and shrinks, and reflections across the x-axis. We're going to start with the horizontal translations, and I usually call these shifts, but a horizontal translation and a horizontal shift is the same thing. If we have just a regular function and we add or subtract a number inside of the function with the x, then what that does is it shifts it horizontally compared to the graph of the original function. If we look at our number in here and we do x minus d, then the shift is d units to the right if d is greater than 0, and it's the absolute value of d units to the left if d is less than 0. That is a really confusing way of putting it because that's counting the minus being in here. So here's an example that might make it a little bit easier. If we add 2 inside of the function with the f, that's going to shift the graph to the left by 2 units. So if this is a plus in here, then it's going to shift it to the left. If it's a minus, it's going to shift it to the right. So this, I think, is easier to remember than trying to remember it this way. Now, when we talk about trig functions, a lot of times instead of calling it a horizontal shift, we call it a phase shift. Now let's do some examples where we're doing one of these horizontal shifts or phase shifts. We're going to start out with a graph of the sine function. First, let's see how much and which direction this phase shift is going to go. Since we're subtracting a number from x, that means that it's going to shift it to the right. So it's going to go to the right by pi over 2 units. That just means we're taking the entire graph and shifting it over to the right. Now what we want to do is figure out for those 5 key points we've been talking about what our new x values are going to be. Let's look at our original x values for those 5 key points. What we're going to do with each of these x values in order to shift our graph to the right, that means that we actually want to add pi over 2 to the x values. So we're going to add pi over 2 to each one of these values. That gives us our new x values of pi over 2. Then here we're taking pi over 2 plus pi over 2. That's going to give us pi. Pi plus pi over 2 would give us 3 pi over 2. 3 pi over 2 plus pi over 2 would give us 2 pi. And 2 pi plus pi over 2 would give us 5 pi over 2. This is where the x values for our 5 key points are going to be. There's nothing else happening with this function, so that's all we're going to do with this is just shift it to the right. And this is going to give us one full cycle of our function between pi over 2 and 5 pi over 2. Now before I draw my new graph in there, I'm going to draw in the original sine graph so that I can see how it's shifting. So for my original sine graph, it would start at 0, 0, would go up to 1 here, come back to the x-axis, go down to -1, and then come back to the x-axis here. With my new graph, with my 5 new locations for my key points, all it's going to do is take this and move the whole thing over. So my point 0, 0 is going to move over to the point pi over 2, 0. My point pi over 2, 1 is going to move over to pi 1, and so on. I'm still going through those same 5 points, so I'm starting on the x-axis, going up to 1, back to the x-axis, down to -1, and then back to the x-axis for the end of the cycle. So now I can label the rest of these points. I've got 3 pi over 2, 0, 2 pi, -1, and 5 pi over 2, 0. There's one full cycle or one full period of my graph. Now, of course, I could continue it going in both directions if I wanted to. So I could continue it back this direction, or I could start another cycle going this direction. Let's look at another graph. This time we've got a cosine graph and we've got x plus pi over 2 inside of the parentheses. This is going to shift it to the left by pi over 2 units. If we add a number inside the parentheses, that actually shifts it to the left. So I'm going to do my basic graph of cosine to start with. Normally I go from 0 to 2 pi. I'm going to plot my 5 key points. Cosine, remember, starts at the maximum and then goes down to the x-axis, down to the minimum, back to the x-axis, and then back up to the maximum. So there's my original graph. Now what I want to do is take those original x values, and I want to shift my graph to the left by pi over 2 units. To do that, I want to subtract pi over 2 from every one of these x values. So if I take each one of these and subtract pi over 2, then I'm going to go from 0 to negative pi over 2. Here, pi over 2 minus pi over 2 would give me 0. Pi minus pi over 2 is pi over 2. 3 pi over 2 minus pi over 2 would give me pi. And 2 pi minus pi over 2 would give me 3 pi over 2. Those are the new locations of my 5 key points. The extra thing that I need to plot here is the negative pi over 2. That's where my full cycle is going to start. It's going to end at 3 pi over 2. So I'm going to take each one of these points and shift it over. So I'm starting here, going down to the x-axis, down to my minimum, back to the x-axis, and back up to my maximum. There's one full period of my graph. Again, if I wanted to continue it on, I could continue it on in either direction, just starting the same pattern again. Let's look at one more graph where we're doing a phase shift. On this one I have a cosine graph, and this time I have a minus pi over 6 inside my parentheses. This is going to shift my graph to the right by pi over 6 units. Here's my original cosine graph. I'm going to take these 5 x values and see what happens to them if I want to shift this to the right by pi over 6. To shift this to the right, that means I'm actually going to add pi over 6 to each one of these. 0 plus pi over 6 gives me pi over 6. Pi over 2 plus pi over 6, I might have to do a little fraction math here. So if I do pi over 6 plus pi over 2 is the same as 3 pi over 6. That gives me 4 pi over 6, and that simplifies to 2 pi over 3. Pi plus pi over 6, same thing. I can write pi as 6 pi over 6, so that is going to give me 7 pi over 6. 3 pi over 2 is the same as 9 pi over 6. That's going to simplify to 5 pi over 3. And 2 pi plus another pi over 6 would give me 13 pi over 6. This is probably the hardest thing about this, is just figuring out those fractional values. These are the x values of my new key points on my graph. And remember, I'm taking this and just shifting it over pi over 6. So that's going to be, if we think of pi over 6, it's pi divided by 6. So that's going to be just about that much. So here would be my first x value, would be pi over 6. My last one is 13 pi over 6, which is just a little past 2 pi. And then I'm just going to take this interval right here and divide it into 4 parts, and I know what those 4 parts are by the numbers I've got here. So each one of these is going to be a little bit past what it was on the original graph. So there are my locations. Now I'm going to label these. So this is 2 pi over 3, this is 7 pi over 6, and this is 5 pi over 3. Now I'm just going to take each one of these points and shift it over. So I'm starting at the maximum, going down to my minimum, coming back to the x-axis, and then back to my maximum. So there's my graph for the cosine of x minus pi over 6. Now I can also do these graphs on the calculator. I'm going to do this one on the calculator just to show you what happens. Sometimes with the calculator it's really hard to interpret what it comes up with. And that's why you really need to know how to find these values by hand. So there's cosine of x minus pi over 6. I'm going to graph this with my Z-Trig window. We can see this is a little bit shifted So the maximum isn't happening right on the y-axis, it's just a little bit to the right of that. But it would be pretty hard to tell from the calculator where exactly this was. So it would be hard to tell where these actual locations of those 5 key points are. So that's why you need to be able to do it by hand. The next thing we're going to talk about is vertical translations. And again, I usually call these shifts. With these, we're just shifting the graph. We're not changing the shape of it at all. This happens when we add or subtract a number on the outside of the function. If we add or subtract c, then this is going to shift our graph vertically compared to our original graph. And this one's easy. The shift goes up if the c is positive, and it goes down if c is negative. Let's do a couple of examples where we're doing a vertical shift. For these, I'm also going to start out with the original sine or cosine graph. For this one, we've got the sine of x. What this is going to do with the -2 not in parentheses is it's going to take the whole graph and shift it down by 2 units. If I draw my original sine graph, it starts at the origin, goes up to the maximum of 1, back to the origin, down to the minimum of -1, and back to the origin. This time what I'm doing is going to change the y values. So I'm going to label these points so that I've got the y values in there. All I'm doing with my vertical shift is just taking every point and moving it down by 2 units. This is only going to change the y values. So for each one of these y values, I'm just going to subtract 2. So my point 0, 0 moves down to the point 0, -2. My point pi over 2, 1 moves 2 units down. That's going to make it pi over 2, -1. My point pi 0 moves down to pi -2. My point that was 3 pi over 2, -1 is going to move down to 3 pi over 2, -3. And this point is going to move down 2 units so that my y value is -2. And now I can just draw my graph through those 5 points. Let's do the same thing with this one. This time I've got this 1 out in front. It's still technically added to my entire function. For this, it doesn't really matter if the number is added or subtracted on the front or at the end, as long as it's not in the parentheses with the x. So what this is going to do is it's going to shift my graph up by 1 unit. My original cosine graph is going to start at the maximum here, go down to the x-axis, down to here, back to the x-axis, and back up to my maximum. For my new graph, it's just going to take each one of these points and move it up by 1 unit. So this point is going to move up so that it's the point 0, 2. This point is going to move up so that the y value is 1. This point is going to move up so that the y value is 0. This one will move up to 1, and this one will move up to 2.